So now we're going to kick it up a notch. And notice we're starting with second derivative. So the first thing I'm going to have to do is integrate on the second derivative. And when I do this, it's going to get me back from where it came, which of course will be first derivative. So now my f prime is going to be, so remember I got to power this one up, so that'll become x to the third divided by 3, or 1/3, and plus antiderivative of cosine is negative sign, so actually that's going to be a minus. So minus 3, no, just kidding, should be plus. Antiderivative of cosine is sine. Plus c, because I always get the general solution first. And now I go, I wonder if I'll be able to get a particular solution. So I hunt around back in the directions and I notice, hey, in first derivative, when x is 0, the y value is 5. So, or negative 5 rather. So I'm plugging in a negative 5. And for the x's, I'm going to plug in 0. So that'll be 0 cubed over 3, which is 0, plus 3 sine of 0. Remember, sine of 0 is 0, plus c. So now I know c is negative 5. So now this leads me back to knowing the specific first derivative, f prime of x, is 1/3 x cubed plus 3 sine x minus 5. And I need that because now I want to go all the way back. Remember, solving the differential equation means get me back to f of x, always back to the original. So now I'm going to take the antiderivative of the first derivative, because I got to go back one more step, and I'm going to split this while I'm doing it. So plus antiderivative of, I'll put this out in front, 3 sine of x minus antiderivative of 5. And so this is going to lead me to f of x when I take the antiderivative. And so let's see, if I power up, I have a 1/3, and then that x is going to go to a 4, and I'll have to divide by 4, plus 3, let's see, antiderivative of sine is negative cosine, so I'm going to change that to a subtraction. Minus 5x, when I increase the power back on this one, will be x to the first, and then plus c, running out of room. Fine, we'll squeeze this over. Minus 5x plus c. Yay, we made it fit. But again, I have some specific information about the original function, and that when y is 1, so we're going to plug in 1 for the f of x, for the y, x is 0, so of course this term will turn into 0, it'll be 0/12, minus 3 cosine of 0, that's going to be a negative 3, minus 5 times 0, plus c. So I find out that 1 equals negative 3 plus c, so c equals 4. So now I can write the original function, which is going to be f of x is equal to, so if I simplify this, I get 1/12 x to the 4th minus 3 cosine x minus 5x plus 4 because my c is 4. That wasn't so bad. So welcome back to our good old friends, position and velocity, and of course the third one, who is acceleration. So as a quick reminder, s of t was position, and then if I took the derivative of that, I got velocity, and if I took the derivative of velocity, or the second derivative of position, I got acceleration. So just as a reminder. And one other thing to note, if you have not learned this before in a science class, probably should write it down anyways, is that acceleration is either negative 9.8 meters per second squared or negative 32 feet per second squared. So you want to remember that, because how you begin this problem is determined by whatever units you're actually given. Okay, so now, when it tells me initial velocity and an initial position, or when it's thrown, so I note here, initial velocity, that tells me something very important. That tells me when time is 0, I have a 64 feet per second. Oh yeah, that would be velocity, right? The unit's velocity is measured in some type of linear length per time. So what I just found out is for velocity, I know this particular coordinate. And I have an initial height. And of course, height is position. So again, that would be when time is 0, height is 80. So this is for position. Okay, so now I want to get back to the original position function, but they didn't give me anything to work with except what I know is that acceleration, since this is in feet, is negative 32 feet per second squared. So if I take the antiderivative, so I say, oh, well, I have acceleration, I'd like to get to velocity first. So I'm going to take the antiderivative of acceleration. Whoops, I don't know what that is. So with respect to t, and that's going to give me velocity, which, powering up, I'll have negative 32, a t back in it, to the first, and divide by 1. I don't need all those extra ones, so I'm going to erase them, but I put them there so that you would remember. And then, of course, plus c. So that, of course, gives me my general solution. So I'd like the specific velocity function. So what I know is, back from up here, that for velocity it's 64, so v of t would be 64 equals negative 32 when time is 0 plus c, so c is 64, which means I have velocity is negative 32t plus 64. And all I'm doing is just writing that over and plugging in for the c value. But of course I'm not done, because I want position function. So now to get back to position function, I have to take the antiderivative of velocity. I should have had some equal signs up here. But velocity is this. So I got to take the antiderivative of that expression I just wrote. And again, if I power everything back up, I'll have s of t equals, so let's see, that'd be negative 32. I'll power up the t and divide by 2. And I'll power up the t, which before it was 0, so now it'll be t to the first, plus c. So there's my general equation. So if I want the specific one, I go back to, oh yeah, I knew something about the s of t. I knew when it was 80, we'll reduce this to negative 16, and t was 0, so plus 64 times 0 plus c, which means c is 80. Well, that makes sense, since my initial position was 80 feet. So now my position function is negative 16t squared, that comes from this, plus 64t, that comes from this, plus 80. And there's my answer for part A.